مش هستغرب لو شفت ديناصور أو بطريق. خلص يا ويب سكور. طب استنى كده نخليه مجرد بس زي ما هو يا مفرقتش. any direction anyhow. أنا مش هستغرب شفت ده إيه ده I'm streaming yeah. أنا يسوع one second. مش هستغرب شفت ديناصور أو بطريق. Why the camera is not working though? Let me check the camera. Oh yeah. Hold on, chat. Yeah. I look so ass. Hold on. I wanna low key try. I'm gonna deactivate actually. I just wanna see myself. I just wanna be myself. Why Friday hate you for me? Just trying to be myself. I mean, that's alright, it's alright, it's alright. مش هستغرب شكلي وحش أوي يا اسطى. Why do I look so bad? Wait, hold on, I wanna try something though. I guess it's gonna be أنا مش هستغرب لو شفت ديناصور أو بطريق. ده الدنيا في حال وحبيبتي في حال. أنا ساموراي Okay, anyhow, this wasn't what we were doing. Okay, guys, I was actually studying math, so it's kind of complicated, but it's not so complicated. It's not very complicated, but I find it a little bit complicated because I haven't studied maths for so fucking long. So here we have methods of evidence, which is chapter 8 and chapter 3 in this book. This book, I guess. Yep, math induction. So let me read this. This is the microphone, by the way. It's not, but I'm pretending that this is the microphone. Mathematical induction is one of the most important methods for proving statements of the form for all natural numbers. At its heart, it's another instance of idea of recursion. At its heart, it is another instance of the idea of recursion. Reduce the problem to a smaller problem of the same kind. Can I get on? So again. At its heart, it's another instance of the idea of recursion. So it's something like the same explanation or the same meaning of the idea of repetition, basically. Yep. Same example of the idea of recursion, which is repetition, something like that. We can use Arabic here. So reduce the problem to a smaller problem of the same kind. So we are just reducing the problem to another problem of the same fucking kind. All right. Hold on, let me use that. So hold on. Here we have our Ben. Anywho, mobile. That's cringe. Mathematical induction. So same problem. Okay, mathematical induction implements this idea for proofs, while recurrence relations. What does this mean? No idea. While recurrence relations are used in problems where you want to determine the quantity. While recurrence relations are used in problems where you want to determine some quantity. Doesn't it kind of low-key doesn't make sense, but while recurrence relations, the relations of these recurrence are used in problem where you want to determine some quantity. Okay, let's continue. In this chapter, we consider two problems where mathematical induction can be used, with more examples to come in the following chapters. We also discuss the limitation of induction. Along the way, you will encounter another important element of problem solving of any scientific work: introducing suitable terms or concepts. The induction principle. The mathematical induction is based on the following principle. Let A n be a statement about natural numbers n. Suppose base case A1 is true. So I think here he means that A is belongs to natural numbers. So A is a natural number. And A, when it's 1, it is true that it is natural number, I guess. Inductive step. Yes. For all n that belongs to natural numbers, the following implication is true. If A is a natural number is true, and A, then A n plus 1 is also true. Then A n is true for all A n. So basically, if some natural number is n, so if it was also another natural number but plus 1, then it should be also true, right? Because some natural number cannot be true while other cannot, and we can give an example of the other number that we want to test by n plus 1 or n plus 2, right? So I guess that's it. In the inductive step, an is called inductive hypothesis, and an is the inductive claim. The inductive principle can be visualized as the domino effect. Put a row of dominoes upright on the table in such a way that each will knock over the next one when falling. Now, if you knock over the first one, then they will all fall. See figure 3.1. Domino effect. Here is a simple induction proof for illustration. Claim for all n belongs to nature. We have, what is that number? How is it if I click this? Huh? Never mind. Proof. So the sum of I I actually do not understand this notation. Hold on. I think I have to. I want to try this. Hold on. 1 second. I've seen. Hey, I don't understand this notation right here. Can you explain it to me?
Sure, it looks like you're dealing with mathematical induction. The notation here is used to prove a statement is true for all natural numbers. The claim is often about a formula that calculates a sum or a sequence. The base case establishes the formula for the initial value, usually n equals 1. Then, the inductive step assumes the formula.
Hold on. I just want to know what does this sign mean, and when the n is here, what does it mean, and when the k equals to 1 here, what does it mean, and what's the k here means. So let's go one by one.
Alright, let's break it down. The symbol SUM stands for summation, which means adding up a series of terms. The n at the top of the summation symbol tells you the upper limit of the sum. The notation k equals 1 at the bottom indicates the starting point. Essentially, you're adding the expression to the right of the sigma, starting with k equals 1 and ending at n. The k in this context is a dummy variable representing each integer in the range as you add them up. Does that make sense?
So are these labels correct?
Yes, those labels are correct. The n at the top is the upper limit of the summation, indicating the last number you'll sum to. The k equals 1 at the bottom is the starting point, showing where the summation begins. And k is the variable that changes value as you sum from the starting point to the upper limit. Perfectly labeled.
So basically, k can be changed. So what if I replaced k by 3, for example? What will this mean?
If you replace k with j, the
No,
meaning
no, no,
doesn't
no.
change. It's just a
I
different
said,
label for the same concept.
I said, what if I replaced k with number 3?
Got it. If you replace k with the number 3, then the summation would start at 3 instead of 1. So you'd be summing from 3 to n instead of 1 to n.
Oh, okay. I get it now. Okay, let's continue. Proof, we use mathematical induction here. A equals to n is a statement that the formula holds for the value n. So A here, this means that basically A equals to n, right?
That's correct. The statement an refers to the formula being true for a particular n. In this case, you're proving the formula holds for all natural numbers n using mathematical induction. So the an represents the statement or formula you're verifying for each n.
hold on, I cannot understand. So an is the statement that the formula holds for the value n. What does this mean exactly? So does this mean that a equals to n or what?
No, AN doesn't mean A equals N. Instead, AN represents a statement or formula that applies to the number N. In the context of mathematical induction, AN typically means the formula or property we're trying to prove is true for any specific N. It's essentially AN is the claim that the formula holds when N.
So can we consider a as a function where n is being inserted in a?
Exactly. Think of A as a function and N is the input. So AN indicates that you're evaluating the function A at a particular value of N. It's a way of saying that the statement or formula in A is being considered for a specific N.
Okay, so here it says base case. The statement a1 is a equals to 1 multiplied by 2 over 2. This is obviously true. Inductive hypothesis, let n be arbitrary and assume an is true. So k the summation mark n at the top, k at the end, at last or at the bottom equals to 1. Is this correct? And k equals to n open brackets n plus 1 over 2.
Yes, that's correct. The statement says that the sum of k from 1 to n equals a fraction of 9n plus 1 over 2. This is a
Okay, and inductive claim so this is the inductive hypothesis. So inductive claim is a open brackets n plus 1 is true, while is true. That is the summation of n plus 1 at the top and k equals to 1 at the bottom equals to n plus 1 n plus 2 over 2.
That's right. The inductive claim asserts that the sum of k from 1 to n plus 1 equals the fraction of n plus 2 over 2. The inductive step aims to prove.
Okay, cool. So here first he said, so I proved that, hold on 1 second, I shouldn't use this one. 1 second please. Where the fuck did I go? Yeah, hold on, yeah. So here basically I proved that this is true, because when I replaced n with 1, it was actually true and I got 1 as the answer. So this also should be true, right? No, it shouldn't be true. Now I'm gonna try to prove it. So since I know that that this equals to this, I can then replace this hold on. Then I can then replace this equation with this notation. So basically I will say that this equals to this plus n plus 1. But hold on, where did the n plus 1, oh, is the n plus 1 is like the addition? I can wait, hold on, is it like hold on, am I gonna say like that sigma k plus 1 n k equals to, and I'm gonna substitute the n by the n plus 1, so I'm gonna say n plus 1 and here wait, hold on, like a bigger bracket so it can be more obvious. N plus 1 here, like n at the top. Hold on, chill, plus 1 and another bigger bracket, and here's 2. So the thing is that I have this here, hold on, I have the n, how can I convert this into this? How can I convert this into this? Or sorry, the opposite. How can I convert this to this?
It looks like you're working on a math problem. Could you click?
How are you saying?
It looks like you're asking for help with the mathematical conversion, but it's a bit unclear what you're trying to convert. Could you give me a bit more context?
Okay, I give up on this actually because it's not like a real human. It's not like a real human. I'm gonna use regular AI. I'll try to tell it what I'm trying to do. I'm not sure, guys. I'm so bad at math, like I told you. So I'm just trying to survive on my own right now, because also I'm not yet in my university. So hold on, let me take a break to refresh my mind. And because my hands are actually a little bit hurting, my hands are hurting a little bit. Anywho, so what was it saying? Hold on, what is that? I put my hands like this. Is it a little bit better, or I think the problem is here. No idea, honestly. Anywho, I'm trying to look in here. So basically here, so okay. Oh my god, email. Oh, it's a security alert. No problem. So let me check this again. So here, claim for all in. What the fuck is this, gang? What the heck is this? We are not even close to this. Okay, hold on. Let me try to rewrite it. To write it and see what is he gonna say, or what is he gonna say. Oh, you know what? I do actually. Fuck. There is no control Z here. Okay, never mind. First of all, I want to open this book here. So open from device. I'm gonna open this book here. I think it's this one. Yep. So it is chapter 3, which is somewhere. What page is it? Page 72. It's 10 page from there. Okay. So okay. Those are not working. I need to fix those two. Where is it, guys? Look at me. Yeah, here it is. I want to change the pencilings into main right click number 1. Okay. I guess yeah, it was number 1, something like that. Okay, so now I have number 1 as this. Okay, I'm gonna use this actually. Okay, lucky. So first of all, I need to prove that this is okay. Hold on, let me actually zoom in here. I have this here. Zooms in here. Okay, I'm gonna write the proof here. Can I write the proof here? Okay, so prove that this. Okay, I'm gonna say A1. So and A1, I'm gonna say that 1 should be equals to 1 plus 1 over 2, which equals to, hold on, I should say like a plus 1, a1, brackets 1 equals to 1 plus 1 over 2, which equals to 1. Hence, A1 is true. Thus, A n plus 1 should be true. Okay. ده اللي أنا فاهمه. That's what. Is this correct? No idea. If what am I doing right now is correct? Totally no idea. Okay, over 2. Okay. So what I can do here is multiply this and then multiply this. I mean, I can do that, for example, so I can say n plus 1 multiplied by n plus 1 plus n plus 1, I guess, over 2. And then actually I can like take the n as a common factor. No, I cannot. I cannot take the n as a common factor. So I can't exactly figure out how can I, like, I need to do it this way, I guess. Cause like the same way as I replaced the same way as I replaced the 1 by n, I need to replace the n by n plus 1, I guess. Here it says inductive claim a n plus 1 is true. That is, n plus 1 is the limit and k equals to 1. So n plus 1, n plus 2 over 2. Or here he means that we are gonna replace the n's by 1, maybe. We should replace the n's by 1, so here's gonna be something like 1 plus 1 multiplied 1 plus 1 plus 1 plus 1. So basically 2 plus 2 4 plus 2 equals to 6, and then divided by 2 is gonna equals to 3. No idea. So how did he get this value right here? So I know for a fact that this is n plus 1 multiplied by n plus 2 over 2, which is equals to n plus 1 over 2 and n plus 2 over 2. And we know that this is n plus 1 over 2, n plus 1 over 2, which is this, basically this. So I can maybe say that I'm gonna replace the n plus 1, which is this part, by, so Bro, what the fuck? He replaced. This is basically like n multiplied by. I got this part. Like, I know that I've gotten this part, which is n plus 1, which is makes fucking sense. Okay, I'm gonna. Again. Let's try this again. Okay, let's try this again. So step by step walk through. I want to zoom in a little bit. Oh, not that much. Step by step walkthrough. Let's go through the proof in your image step by step. The statements what we want to be proof, what we want to prove for every natural number n, the sum of the n positive numbers, 1 plus 2 plus 3. So the sum is like adding them all is gonna be equal to this. Okay, let's call the statement a n. So the first statement is called a of n, which means that the sum of any number with the sum of any of the first n positive numbers is gonna be in this equation. Alright, sounds good, sounds great. Base case. We start with n equals to 1. The left side, on the left side we have k 1, k equals to 1. On the right side we have this. We replaced 1. Cool. Inductive hypothesis. Temporary assumption. Suppose that the formula is true for some arbitrary n. This means that yeah, we already proved that. Inductive step. Proof for n plus 1. We must show the formula works for n plus 1. How the fuck did you get this? How do we get this, the sum of this step by step? Oh, suppose we want to add up this. Write it backwards. N plus n minus 1 plus n minus 2 plus till the end. Add the two rows term by term. Add the two rows term by term. Line up and add. S 1 plus. Okay, so I need, first of all, I need to understand this part to get the last. Okay, and you want to tell me that if I expanded this, it's gonna end up. So, huh? Nigga, what? How? Explain yourself. Oh my god, did I forget how to expand or what? Did I genuinely forget how to expand or I have no idea what the fuck? The equation is right here, bro. The equation is right here. So we say n. Sleep, what the fuck? N plus 1. N plus 1. So this basically is gonna be n plus 1 divided by n plus 1 plus n plus 1. Can I say that this is basically 2n plus 1? Fuck no, I don't think so. I think that we need to multiply them together. So n multiplied by n is n bar 2 plus الأول في التاني في 2. No. Plus this multiplied by this multiplied by this is n. Okay, 1 plus n plus 1. How the fuck am I get rid of this one? I have no idea. Well, hold on. If I multiply this by this, how did you plugging it in? Okay, plug it in. Simplify the formula. Oh shit! Oh my lord! No! No, I'm so dumb. What the fuck? Okay, my bad. I'm so dumb. Okay, so we are starting for first switch the formula, but the m is replaced. Here's okay conclusion. We can verify it for the formula n equals to 1 base case. We showed that if this works for n, it also works for this. The formula works for all natural number by induction. The inductive step always add a number here n plus 1 to obvious no sum of both sides. We substitute the assumption for n into the sum for n plus 1. We combine a factor to match the structure of our original. Okay, I think I get it. I think now I get it, guys. I think I get it now. I'll just like to open this and close it again just to remove the notification because I'm actually waiting for something right now. So, practical note: after a while, the correct use of mathematical induction will become second nature to you. Until then, it's useful to write out inductive hypotheses and inductive claim fully in order to avoid mistakes. Often use variants of induction principle. Here are some variations which can also be combined. You will find examples in this and the next chapter. Is replaced by for all n greater than 2 we have an. What the fuck is going on? From now on we use this summation notation. See the list of symbols. So is was basically basic statement. Is is induction statement, something like that. Induction hypothesis or what? Yeah. Inductive step. For all n, the following implication is true. Base case. Okay, so what he's saying here that practical note. After a while, the correct use of mathematical induction will become second nature to you. Until then, it's useful to write out the inductive hypothesis and inductive claim. What does inductive claim even mean? No idea. Fully. In order to avoid mistakes, often we use variants of the induction principle. Here are some variants which can be combined. You will find examples in this and the next chapter. Okay. So BC for n. BC for n equals to 0, is for all. Okay, hold on, I need to understand some of it. First of all, I need to understand this part here. Is replaced for all n greater than 2. We have a n or a n. Okay, let's move on. BC for n equals to 0, is for all n greater than 0, more generally BC. N equals to n0 is for all n greater than n0, where n0 is the same natural number. Is replaced for all n belongs to a natural number. We have a1 imply this BC a1 and a2 are true. If all n belongs to n to nature, we have an plus 1 imply an plus 1 plus 2. Okay, so the thing is that mathematical induction. We talk about the stuff here. Okay, I'm gonna use this. Okay, I'm gonna listen to organic chemistry. Hold on, I wanna check for something. Look. The fuck? No one fucking knows him. That man is the fucking goat. Someone get this guy so we can. That man is actually fucking amazing, guy. Algebraicus. That man is actually the goat. I swear to God. Or that guy. That man is fucking him. I wish there's a podcast. Okay, chill, 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 chill. Mhm. Mhm. Okay. It said for n equals to 1, the first number is 3. So number is also equals to one. So it's basically why not though? Yeah, okay. Okay, so basically the first one. So hold on, one multiplied by equals. Wait, hold on, will I get copyrighted if I keep watching this? I don't know. I mean, no one is watching, so the thing does not matter. Okay. 21. Oh shit, it's true too. Can I take a break? I want to take a break. I'm gonna take a break. I'll be right back, guys. So, so I have like You're, 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 you're. Okay, let's go. Lock in. Three plus seven plus 11. Okay. Hello. Yeah, this is the next number. Are equal. Yep. Here, for k plus 1 minus 1 equals 2k plus 1. I think we're gonna just replace the k with 1 because we just need a number for k. 2k bar 2 plus k. 2k squared plus k, yeah. 4k plus 4, so 4k plus 5 plus 3. 2k plus 2 plus 1. Yep. 2k bar 2 plus k plus 4k plus 3. Oh shit, it's gonna be the same thing as that. Okay, okay. So it's gonna be basically the same thing. Alright. Mm-hmm. Mm-hmm. Okay. You know what? One thing I think I might do is multiplying this by 4. 4 equals to 1. Alright. Plus 2 over 3 to the third power equals 2 to square plus 2. Okay. Okay. Equals okay. Okay, low-key kinda forgot to understand what it was. Already, I'm so fucking sleepy. I'm gonna switch out the stream of this and go to sleep. So n equals to k1 bar 3 plus 2 bar 3 plus k bar 3 k bar 2 k plus 1. So basically I replace it with k. So n equals to k. What the fuck? Yeah, so now just basically replaced it. So I have this, and then I'm gonna say n equals to k plus 1, and I'm gonna replace the k by k plus 1, and here too I'm gonna do the same thing. Then I'm gonna simplify it basically, but I can't replace this because basically I can replace it by the k bar 2 equals k plus 1 over 4. Yep, plus the k plus 1 over 3 equals 2. type shit. Guys, this pen is that. Okay, I think I'm gonna go sleep actually. But I do now understand this word, so I can actually move on some of the first numbers. I low-key can move on. Okay, various limitation of induction to start at different space causes values for n. Okay, honestly, I cannot understand shit from this thing where I think I'm gonna just use the book. Makes more sense. Problem. Okay, there is some other stuff here that I cannot figure out right now. Think about it. Think about it. Review problem. I'm gonna do